Hi, this is Mr. Max. So I am doing paper 2 of the AS level that was written on the 25th of August in Erongo region. I'm only going to do questions 1 up to question 9, and then I will be uploading the others tomorrow, question 10 up to question 12. Okay, right. Let's also make sure that you understand as ever, you understand the degree of accuracy, the instructions that are coming there. And from time to time, you will be needing to change your calculator to degree mode and then also to radian mode depending on the question. So you should be familiar and quite comfortable dealing with both. Okay, so when you have answers in radians, they will be given to 3 significant figures, and when the answers are in degrees, they will be given to 1 decimal place. Right, the first question has to do with absolute value equations. The way you can solve this, I hope you still remember, this is just 3 marks. You're going to sort of square both sides, okay? So let's just change that color maybe to red. So you're going to say 9x minus 2 all squared is equal to 3x plus 2 all squared. Well, you should be very familiar how to multiply out binomials, and this is going to be double of 9 times 2 is 18, double of 18, that is going to be 36x, and 4 to negative 2 times negative 2 gives you 4, right? And on the right hand side you have got 9x squared, and then 3x plus times 2 is 6x, double of that is 12x plus 4. Once you're here, when you have the same thing with the same thing, you can just as well, sort of cancel them and just have the terms to the left, because it becomes a quadratic. That is equal to 0. So I will have 72x squared here minus 48x. And of course, you should know that 24x is a common factor, and 24 goes there, 3x minus 2, and you can say set 24x is equal to 0, or 3x minus 2 is equal to 0. Okay, right, then from there obviously you can solve the values of x. Then x would equal to 0 on this side, or x is going to be 2/3, and this is our solution as we are requiring them. All right. 3 marks for that. Let's go to the next question. So hence you have to use your answer in part A. So just before I use the answer in part A, I just like to rewrite this. What I have here, I'm going to rewrite this stuff. Okay, I'm going to rewrite this stuff as 3y times 9. That 9 comes from 3 squared minus 2. Okay, and then you say equals to 3y times 3 plus 2, that is like power 1. So what you're doing here is, if you're familiar with the split rule, if the bases are the same, you add the indices. Okay, so I just work backwards, so to speak. So I know that if the bases are the same, I'll be adding the indices, which will give me what I have over there and over there. Now let me just continue to clean this up. So this is nothing but 9, I'm just going to write the number in front, times 3 raised to the power y minus 2, keep them in the modulus sign, the absolute value signs, and that is equal to, again, I'm going to do the same. I'm going to have the 3 here, times 3 to the power y plus 2. Now let me just bring the equation that I had, or the absolute value that I had, 9x minus 2, from part A. I'm talking about this one over here. So if you compare, you have something like 9x minus 2 is equal to 3x plus 2. Having done that, you should definitely be able to realize that this value here of x can be equated with that value because it's everywhere going to be the same. It's like that 3y is taking the value of x. So therefore, x will be equal to 3 raised to the power of y. But now we have our answers from part 1. We know that x is 0, and we also know that x is equal to 2/3. That is from part A. So if we take 3y to equals to 0, okay, or we take 3 to the y is equal to 2 over 3. Well, of course, this won't work because I have to take the logarithms or the natural log of both sides, and you can't have the answer, the natural log of 0. So here, I will have that y, which is like the natural log of, taking natural log both sides. So I'm going to have the natural log of y of 3. So bring the y in front, so that's natural log of 3 is equal to, remember the y is over there, so taking natural log on both sides, now the y comes in front, is equal to the natural log of 2 over 3. Well, you can actually clean this up if you if you if you divide throughout by the natural log of 3. So this is going to give me the natural log of 2 over 3, and that's going to divide by the natural log of 3. Of course, this is a little bit too um, condensed here, so let me just bring in a page, and I hope that page is going to be at the right place. Okay, so that I don't have to rewrite everything. So I have got y natural log of 3 is equal to natural log of 2/3, and then I will divide throughout by the natural log of 3, so that's that here should be divided by the natural log of 3. Now, are they asking for the exact answer? No, they are saying give your answer to 3 significant figures. So we'll just grab our calculator and we'll do this the answer on the calculator. So let's see. So that's the natural log of 2 over 3. You should divide that by the natural log of 3. Okay, right, that answer over there, I'm just going to copy it. That is my answer that I have. So therefore I will say, okay, my y value then, my y value would be y equals to negative 0 point, they say to 3 significant figures, 369. This is correct to 3SF. Okay, that is the answer to that. Of course, you are supposed to always be careful for the hands questions. Right, now let's come to question 2. Question 2, we have a scenario here where you are given the graph of the natural log of y against the natural log of x. So what is important for you to remember here is that this can be written, let me just write it down. I have y equals to a times b raised to the natural log of x. Now, this first thing that I'm going to do, I'm going to rewrite this as, so the first thing I will do, I'll say this is the natural log of y is equal to, let me put the natural log of a using the properties of logs now, multiplying, so I'm going to add, and then the natural log of b, and obviously that is in front over there, so I'm just going to bring it down, so that's the natural log of x. Okay, so I'm just going to put this in bracket just to indicate something. All right, so I can just rewrite it so that it can be in the form of y equals mx plus c. So the natural log of y is equal to the natural log of b. Then I have natural log of x plus the natural log of a. So now it's in that form, y equals mx plus b. So since the graph of the natural log against natural log of y against the natural log of x is a straight line, the slope of the graph, the gradient, is the coefficient of the natural log of x, which is the natural log of b. So this one here, this is our gradient. Okay, this will be our gradient. So this is like y equals mx plus c. So our gradient is the natural log of b. Now we have our points that we can actually use to find that value. And when we go to our graph, we have got the points 11. So this is a point, one value of x here, and that's another value, not x rather, but y. Those are y values. So this is a y value, let's say y1, and that is y2. And similarly, this one over here will be x1 over x2. So I'm just going to subtract the two in order for me to find the gradient. Okay, so I'm just gonna make sure that I copy those values down, see if I have enough space. Maybe I'll need to enter or bring in another page. Okay, so let's do that so I can actually calculate the natural log of b. So first we can find what is that gradient. So that gradient is 11.008 minus 4.908. That would be the difference in y's, and then we're going to divide it by 5.9. That is the difference in x divided by 2.2. Let's just make sure that we have written the correct coordinate points. Right, so you are going to get a value of the natural log of b is equal to 1.6486, more or less. Okay, now if we have to find b, remember this is nothing but log base e of b, so b will simply be e raised to that power 1.6486. This natural log of b is the same. Okay, always remember that the natural log of b is the same thing as log base e of b. So that's what I'm doing. So I'm rewriting it from an exponential form, right? And that's going to give me the value of b. They are saying we should give the value of b correct to two significant figures, if I'm not mistaken. So the question says a and b should be given to two significant figures. So to two significant figures, that's going to be simply 5.2. Now let's go back to our we are going to sub that value of b. So we're going to substitute. We are going to substitute the value of b that we got, okay, into our equation, into the equation to find the natural log of a. We're also going to use a point. So I'm going to choose which point to use. So let me just go back to my diagram, and I'm also going to bring in here we actually don't have to worry too much about that. So let's just take a snapshot of it. I want this diagram over here, the new place where I'm working. I'm also looking for my equation that I have done so far. So take this snapshot of the equation, maybe the whole of it. Okay. What else do I need? Well, I know what the point is. I know what the natural. I know what this value is. Okay. I have that value of the natural log of b. Okay. So it's this value that I'm going to replace, not just the b value, but the natural log of b. So I'm going to replace this whole value here, natural log of b. Okay, I'm going to replace it with this stuff over here, the 1.648, because that's the natural log of b. All right, so let me also take a snapshot of that and bring it over onto the next place where I'm working. All right, okay, and then obviously I'm going to use a point, so I'm going to decide which point I'm going to use. It doesn't really matter. Okay, so let's go. Let's also save. because we know how this works. So the natural log of y, we will replace that with this y value, which is 4.908 because it's on that axis, and that equals to natural log of b, that was 1.6486, okay, and this should be multiplied by the x value, which is 2.2 that I have here, and that should give me the natural log of a. Right, so the natural log of a should be this whole stuff here, 4.908 minus, okay, this 1.6486 times 2.2. Okay, now what do we get? So we get a value, let's just grab our calculator to make sure what our answer is. So we'll get a 4.908 minus 1.6486 times 2.2, 1.28. Okay, so I'm just going to write that down. So it's like 1.280 0.08, and that is the natural log of a. Now remember, natural log of a is log base e of that. That's the same as log base e of a. That's what it is. So I'm just going to take, sometimes it's helpful to do this. So you're going to say e raised to that to find the value of a. It will be e raised to the power of 1.2808, which roughly will give me the value of a. So use the calculator. So we're going to say our e, shift where's our e. We're going to raise it to the answer. That's about 3.6, okay? So it's 3.6. This is obviously correct to 2SF as they were requiring us to do. So therefore, you can actually conclude, you can say, therefore, A is equal to 3.6 and B is equal to 5.2. Correct to two significant figures. Right, so that's the end of that question. Let's go to the next question. Question 3. You were asked to solve an equation here. This equation is given to you in terms of the natural log. So very careful whenever you're dealing with natural log, or logarithms. There will be, if you get negative answers, there will be answers that you have to probably disregard. Okay, so it's one of the steps that you have to remember. Okay, so on this side, I'm going to have the natural log of 2x squared, bring back that of 2x squared minus the natural log of x plus 3 is equal to the natural log of 2 raised to the power 4. Right, I want to have it, we have the natural log of m is equal to the natural log of n, where we then say m should equal to n. That is the property that I'm after, that I'm looking for. Okay, so on this side I'm going to have, okay, so this is natural log of 4x squared, if I have to square everything inside there, minus the natural log of x plus 3 is equal to the natural log of 16. Now this becomes, using the properties, when you subtract logs of the same basis, you divide the numbers. 4x squared all over x plus 3 is equal to the natural log of 16. Now I'm there now where I need to be with regard to this property over here. If I have the natural log of something with the natural log of something, I can just go ahead and I can drop them. At the end of the day, I'm just having 4x squared over x plus 3 is equal to 16. You can just as well put that 16 over 1, and then you can put this in brackets. It becomes an algebraic problem that you should be able to solve. Right, so cross multiply if you were, then you have 16 here, you have x plus 3, then you have 4x squared, 16 times 3, bringing it over, that becomes negative 16x, 16 times x rather, minus 16 times 3, and then 16 times 3 is 48, so it's going to be negative 48 is equal to 0. I can divide this equation by 4 to reduce it. I have x squared minus 4x minus 12 is equal to 0. And this should factorize, okay? And this factorizes, so that's going to be x, that's a negative, so one bracket is positive, another bracket is negative. And what are the numbers? Well, it's positive 2 and negative 6. So x is equal to negative 2 or x is equal to 6. So let's just quickly go back in our original equation. Let me just bring it. Let's save and also bring that one down. This equation over here. So if I bring my equation back here, I am going to see that, wait a minute, the value, I cannot have negative 2 because the moment I put negative 2 in here, it will not work. So negative 2 will be rejected. Okay, so therefore x is only equal to 6. And that is the only solution. Okay. Right. Then let's go to question 4. They say a curve has a stationary point. Now they are giving you the point 3,9.5, and then they say, and has the equation, and the equation is given to you, the dy dx is given to us ax squared plus a square x, where, and this is important verbs to note, a is a non-zero constant. So if we were to do something and we find that we get an answer of 0 or less than 0, then we are not less than 0 but 0. The moment we get 0, then if we get a equals to 0, we will not be using it because of this concept, because they say a is a constant but it's not 0. That's what that means. Now what you have here, this is the derivative, but then if you take the x value, because stationary point, right, means dy dx at this point x is equal to 3. This dy dx is going to be it's going to be 0. So I have got a square plus what is it, a square x, and that should give you 0. Okay, but now I will substitute my 3 in here for the place where I've got the x, obviously. um, did I write it correctly? I did not write it correctly, so let's just make sure we write it correctly from the way it is, right? So when x is equal to 3, that is a plus a square. Of course dy dx is going to equal to 0 because it's a stationary point. So let's just go ahead and substitute our point 3 in here, a point 3 in here. So that's 9a plus a square times 3. Okay, so maybe I can put the 3 in front. That is just going to be plus 3a squared is equal to 0. Now this factorizes. Taking 3a outside, I will have 3 plus a is equal to 0. Then I have 3a is equal to 0, and this is a cannot equal to 0. So the next one that I must consider, I have to consider that 3 plus a equals to 0. That means a is equal to negative 3. And this is going to be my solution. A is equal to negative 3. Right? It cannot be the 0, 1. Good. Now, find the equation of the curve. Right, so let's just complete what we have over here now. We know what a is. Our a value is negative 3. We have dy dx, which was originally given to us as a square, now ax squared rather. I'm just rewriting it, it's not necessary, but just to create space there, ax square. Let's just go back and see. It was ax squared plus a square x plus a square x. Now what do we know? We know the value of a. Our a is negative 3. And we also know, okay, so we know our a is negative 3x squared, and then plus So that's negative 3 squared x. So this equation, the equation here is, or the derivative here, sorry, dy dx is minus 3x squared plus 9x. That's what the derivative is. So dy dx is equal to that. So if you have to find the antiderivative, right, you are going to integrate, you're going to integrate this to get the curve. So if I integrate, there's a couple of terms, so go ahead and put brackets. Okay, it's indefinite integral, so you must have the plus constant of integration, of course. But our equation will be complete because we'll be substituting a point in here. So add 1 to the power, that's negative 3x cubed, divide by that power, plus 9x, add 1 to the power, divide by that, plus the constant of integration. You can actually clean it up a bit if you wish to. This is going to be nothing but minus x cubed. Let's leave this one as 9 over 2x squared plus the constant of integration. Right. Another thing now that I'm noticing is they're asking us to find the equation. Now we have a point, we're given a point right from the beginning, and that point is right over here. That point is right over here. That is the point 3, 9.5. So I'm going to bring that point here, okay? Because that's a point on the curve. They are saying a curve has a stationary point. So that's the stationary point, but it's on the curve. So the point 3, the point. So I'm going to use that point to substitute it in, okay? So the point that I'm given is the point 3, 9.5, if I'm not mistaken. Yes. So we have our curve. So our curve is y equals to minus x cubed plus 9 over 2 x squared plus c. We'll have to substitute for x here and for y in order for us to find that c value. So when y is 9.5 minus x cubed, x is 3, plus 9 over 2, x is 3 squared plus c. Okay, want to see what is our value. So maybe again, let's say first, and then we append the page. Right, so if you were to use your calculator, so again, let's see, we use this in order to bring in the mixed numbers. So remember that, so there's none and 1 over 2. 1 over 2. Well, this over here becomes nothing but negative 27. Okay, so if you have negative 27, is it negative 27? Yes, negative 27. So if you bring it over, you are going to see, we're going to add, is it? Because this is negative 27, so it's 3 cubed, it's negative 27, right? So let's see if we minus 27 or we add 27 because it's negative, so plus 27 minus 9 times 9 is 81. This is 3 squared, that's 9. 9 times 9 is 81 over 2 minus 81 over 2. Let's see. There we go. The value of c is negative 4. So c is negative 4. So what is our equation? Therefore, our equation is, let's just get the rest of it. It's actually over here. You can just check from here. It's minus x cubed plus 9 over 2 x squared, or you can say 4.5 x squared, and then minus our 4, which was our constant of integration. Good. So at the end, this is what you have, and that is the final answer to that question. We're looking for the equation of the curve. So very important, if you have the gradient function, you have to find the curve. You are going backwards. To go backwards, you have to integrate. Right, let's go to part C. They say determine showing all the necessary working the nature of the stationary point. So for you to do that, you obviously have to do your second derivative. But what was our dy dx again? Our dy dx was minus 3x squared plus 9x. Okay, let's just go back to confirm our dy dx right somewhere up here. That's why you see I have actually put that in that little cloud there because I knew I would have to come and use it. Right. So the second derivative, we're going to derive, my goodness gracious, we're going to derive that again. So the d square y over dx square, that is just notation, it's going to be minus 6x, take 1 away from the power, plus 9. So that is the second derivative. Now, they are saying we have a point, remember? Okay, determine the stationary point. Now the stationary point was the point 3 comma 9 and a half, and I'm really interested in the x value. Okay, the x value, because this is in terms of x. So when you have the second derivative, okay, and x is equal to 3, what is that giving me? It's negative 6 times 3 plus 9. When you do that, you will see that you get an answer of negative 9. And because the answer is less than 0, okay, that tells you that that stationary point is a maximum point. We clear? Good. Let's save and go to the next question. Question 5. Now, there's a lot in this question. Maybe we'll have to add more pages as we go along. The expression f of x is defined by f of x is defined by f of x is equal to 12 sine x cos x plus 16 cos square x. Now, there's a lot of identities here that you need to know. So they want it in the form of r times the cosine of 2x minus alpha. This is supposed to be alpha. This is alpha, okay, plus k, where r is greater than 0 and alpha is an angle that is between 0 and a half pi radians, and k is a constant. State the values of r and the values of k and give the value of alpha correct to 3 significant figures. Now, for AS level, this question is not really acceptable. It's more like a level, because you have a 2x here, and we seldomly ask that. Our syllabus is really quite straightforward when it comes to that, and I have the syllabus over here, and this is the part that I'm interested in. You have to find expressions in that form. You can see there's no 2 in there. So again, it's not a maybe most of the candidates will not be able to do it, but there are still some concepts that are relevant, and as I'm doing them, you're going to see. So you should still be able to do quite a number of things. Right. Now, if f of x is equal to 12, and I'm going to say sine x, okay, what is it? Cos x plus 16 cos square x, right? And then that is what you have. And we have to prove that we are going to write in that form. Now, let's just clean up a bit. This here, I can take out a 6, and then I will have a 8, okay? And this 8 here, I will have something, here. Let me just do that. Okay, just like that for now. So what I want to bring in is I want to bring in something called the double angle. Like, for example, if you have the angle sine 2x, okay, remember sine 2x, if I have to take it away from here, I'm just going to write what that double angle is. So I have sine 2x is the same as saying sine x. This is sine 2x. So this is just a bit of side work that I'm introducing. Okay. So at the end of the day, this is sine 2x is the same as this, and I hope you know from your compound angle that sine 2x is sine x cos x plus cos x sine x, which just gives you something like 2 of these sine x cos x. Can you see that? So when I have this, I'm going backwards. So if I have sine x cos x, right, that is exactly this. But then you can see I took out a 6 because if I have to go in there, I know that 6 times 2 sine x cos x. Can you see that? Right, so now I know that 6 times 2 gives me 12. So I just wrote this in terms of that. I'm still going to change this to sine x cos x, and I'll write it like this. Obviously, this is going to be replaced with this one over here, okay, when I continue. Now, let's do another one. What about that cos, okay? So in here, let me just actually go ahead and write it. So I'm going to have 2 cos square x because I know that 8 times 2 gives me that 16. So I'm interested in the 2 cos square x, and there is a reason why I'm interested in the 2 cos square x. So I'm going to come back to, and I hope by now you know and you recall your identities, okay? And I'm going to look into the cosine one, not identities, but the compound angles, all right? Now, if you were familiar with cos, and I'm just going to, let me see, if I'm saying cos of 2x, and I'm going to rewrite it as cos of x plus x, because that's what it is, right? And I hope you remember that cos x, if you have to do that, that is cos x times cos x, you can find this in your formula, minus sine x times sine x. Okay, so this eventually gives me something like cos square x minus sine square x. Okay, so this is cos 2x over here, right? You should be familiar, with your formula. You do get your formula, and in your formula you have cos a plus b, and then you're going to get stuff like that. Now, there is a reason why I did all of that. So let me just add a page, because again, as I said, there's quite a lot that is going on here. And let's just save, because I have that funny feeling that this thing is going to freeze up on me. Okay, so I'm going to bring back this part that I have done. I'm going to bring them, and I'm going to just paste it over here so that I can continue with it. And remember, I have got cos, I was working with cos 2x here, but now that cos 2x, this is not the only time. In fact, let's just go down. This double angle can still, there's still other parts, right? Cos 2x can also be written making, I hope you remember from cos square x plus sine square x, which is equal to 1. If you were to make cos square x the subject, the formula is 1 minus sine square x. And if you were to replace this, then okay, let me at the same time also make the other one. If I make sine square x the subject of the formula, sine square x, that's going to be 1 minus cos square x. So from here, I'm going to see where I have cos square x, and I'm going to replace it with this to see what the other ones are, because there are 3. So cos of 2x is the same as, replace that with 1 minus sine square x minus sine square x. This is going to be 1 minus 2 sine square x, right? And let me just go ahead and put this thing like in a cloud. So there's one, and this is another one, okay? So if I was now to do, if I was to make this the subject of the formula, all right, then I'm going to replace that part. So I'm going to have something like this. I'm going to have cos 2x is the same as, now remember, we have sine x squared, so I'm going to say cos square x. Where I have sine x squared, I'm going to replace it with 1 minus cos square x to find the other one. And let me just clean it up, this one. Okay, if I was to remove the brackets there, I'm going to have something like cos square x minus, in fact, let's just say plus cos square x minus 1. If you were to distribute, this gives you 2 cos square x's minus 1. And this is the second one that I have. Okay, or the third one that I have. So there are 3 to these double angles for cosine. Right, which one am I going to use? Now, it's very important. Can you see that this here that I have inside, I have at this 2 cos square x. So what I'm going to do, I'm going to replace that. Okay, it's very important. You can see that I have 2 cos square x. Right, so I'm going to write this as, first things first, in the place of the 2 sine x cos x, that is just going to be replaced now with sine 2x. Okay, I can use a different color there. That is going to be replaced with not 2, rather a double angle sine 2x. That's what that means, right? Remember, I've done it way up here. Okay, the one that I've done over here. So it's the one that I'm indicating here. This sine 2x is the same as that. So where I have that, I'm going to replace that with that one. Now, I must now decide, okay, what am I going to replace? What am I going to replace here? I've got 8. This 2 cos square x. So I'm going to use this one. Right. But in its place, I have, this is just 2 cos square x. So, but that thing is 2 cos square x minus 1. That's what it is. So there is a minus 1 here. So what you need to do is just add a 1 in here, all right, cleverly, so that this still works as what you call it. It still works as um, 2 cos square x, right? So what did I do that for? You see the part that I have in red. I'm going to replace that by the double angle. So this part is now going to be replaced with, so let's just start. So it's 6 sine 2x plus 8 in bracket. This part here will now be replaced by, you guess it right, cos 2x plus 1. There you go. All right. Now it's just a matter of you know, multiplying out that 8. So we have 6 sine 2x. Okay, there's no need actually to put brackets in that. 6 sine 2x, because it's just 6 sine 2x plus 8 cos 2x plus 8. Okay, so I'm going to put brackets over here. I'm going to put this in bracket and that in bracket. Okay, because they eventually were looking for a scenario where they ask us to find our k. Now let's just compare what we have. We have we can calculate, and another thing that is important, maybe I should add something over here. I should add a page for you to see what is it that I'm about to do. I can actually calculate my R already. See why I said this question wasn't really so advisable. But I can calculate my R. My R is just a number, 6 square plus 8 square, take the square root, okay? And that is the square root of 100 which is 10. So our R value is that. So at the end of the day, I'm just going to write the stuff down. I'm going to write, I'm saying equals to here. You'll see why, because it's an identity that I'm comparing. Plus 8 cos of 2x plus 8. Okay. Now let's just go and grab what this is equal to. They are saying this should be, we should show that this is equal to, now I took this off. I'm just going to, so it doesn't look so bad, but that's an alpha, not that symbol that you have over there, that's like proportion. So if I were to take a snapshot, we are going to rewrite that in that form. Okay, all the way, I'm going to bring it down. So that's why I have the equal to, we want that to equal to that. So let me take that and just say, okay, we know what R is. So R is 10. Okay, this is equal to this. And then I have cos of 2x minus 2x minus alpha, right? Plus k. We also know what our k is. Our k is actually 8. So there we go. Now I am just going to be interested in so this is 10 cos 2x minus alpha plus 8. So objective is for us to calculate our alpha. Okay. So our R is 10, our alpha is that. We know this already. Now let me just take this part of it. Let me just take the point that I want to make. Let's just take cos of 2x minus alpha. What does it mean? And I hope you're familiar, and I hope you have that, cos of a minus b. If you have this, it's cos a, cos b minus sine a, sine b. This is supposed to be something that is in your formula sheet that you are getting at the end of the question papers. Right. So I'm going to use that. That's the reason why I'm doing that. Okay. So I'm going to use that application over here. So this becomes cos 2x cos alpha. That's a minus, so this becomes a plus. That's a minus, so this is a plus, right? So this is going to be sine, okay, 2x sine alpha. So I'm just going to rewrite that. This is the same. Remember, I know what my R value was. My R value was 10, okay? Just very important that I want to do that. So I just want to compare. So cos 2x minus alpha is equal to, I'm going to rewrite, I'm going to say cos alpha first, and then I have cos 2x. I'm just rewriting this, okay, rearranging them, so to speak. Then I have sine alpha, and then on this side, I'm going to have sine of 2x. The reason I'm doing that is I want you to compare coefficients. Compare coefficients from this part, this little teeny weeny part over here. So I'm just going to highlight this, just this part. Okay, we have no worry at the moment. We got our k, we got our r. So that 6 sine 2x, okay, so that is 6 sine 2x. I'm just going to rewrite it like this. And what is the other one for cosine? It is 8 cos 2x. So that's 8 cos 2x. So the coefficients that I want you to compare is this one over here with this one over here, and this one over here with that one over here. They are the coefficients of cos 2x and sine 2x respectively. So what does that mean? If those are constants, they represent constants. So cos alpha is equal to 8. That could be my second equation, or even my first, doesn't matter. And my other equation will be sine alpha, the ones in yellow, is equal to 6, and that is my second equation. So what am I going to do? I'm going to say take equation 2 divided by equation 1. What does that give me? That gives me sine alpha over, okay, cos alpha. That is equal to 6 over 8. Now, what is sine alpha over cos alpha? If you know, you know. It's tan alpha equals 6 over 8. You can actually you can actually sort of simplify that to 3 over 4. Okay, let's add another page. See, it's horrible. Too many pages. Let's save it as well. But I'm very close to the end, just calculating our alpha. It's also important that you know that it's either degrees or radians, but we'll go back. So our alpha will be then the inverse tangent of 6 upon 8. All right, so what our domain is given in terms of, let's go back all the way. Our domain is given in terms of radians, and if that is the case, then we have to make sure that our calculator is set in the radian mode. So let me bring that one down all the way over here. Okay, our domain is given in terms of radians, and if that is the case, then when I grab my calculator, I must make sure that my calculator is in radian mode. So at the moment it's in degrees, so let's just change it to radian mode. So shift, change it, set up to radians 4. Now inverse tangent of 6 over 8, can actually simplify that, but just give you the same answer, right? So that's the answer over here. That's what we get, right? So they say we must give our alpha to how many significant figures? I just forgot a little bit. They say give alpha correct to 4 oh my goodness gracious, that is way too dark for my liking. Give alpha correct to 4 significant figures. Okay, right, our alphas will be 4 significant figures. So what do we know? We know now that if we have to write our final answer is 12 sine x cos x cos 2x, no? Cos 2x, I believe, was it? It was our original equation. Cos x, rather. Why did I say cos 2x? All right, so you write it nicely here. This cos x looks horrible. Okay, cos x plus 16 cos square x, we know is equal to 10 because our r is 10, calculated it before. Cos of, in brackets, 2x minus, they say to 1, 2, 3, 4, so that's 0 0.6435 radians, and we also know our k was plus 8. Right, that was quite a handful for that question. Right, now I will definitely need this perhaps in other questions, so let me just go ahead and take a snapshot of it. So I'm just going to take all of this because I might be required to use it. They say find the smallest possible value of x for which, let me paste this over here, for which f of x is equal to 17. Now f of x equals to 17, so we're going to find theta x, that's the angle that we need to find, what that angle is. But I'm going to use this side. So I'm going to say, since the left is identical to the right hand side, so we can just go and say 10 cos of 2x minus 0.6435 plus 8. That should equal to 17 that you have over there. So that's 10 cos of 2x minus 0.6435 is equal to, take that 8 over, that's going to give you 9. Then cos of 2x minus 0.6435, that's going to be 0.9. Of course, I get that by dividing 9 by 10. Okay. Now, let's see. Let's find our base angle. So our basic angle will be the inverse cosine of 0.9. Let's see what that gives me, because this is in radians, remember. The inverse cosine of 0.9, that gives me 0.4. Let's just capture that. I'm going to put it here. Okay. Let me also then save and just bring in another page. There's so many pages. Okay. Okay. Where are we at? Yes. I'm going to come back to that part. I'm seeing that they are so closely related there. Let's just continue with it here. All right. So if that is the basic angle, and we know that it's cos 2x minus 0.635. Okay. So what was our domain? Were they giving us our domain for theta? Okay, they just want the smallest possible angle, so it has to be the smallest angle, so it must be the first quadrant. Okay, so if you have, because it's also positive over here, so I'm going to say that in the first quadrant I'm going to have 2 theta minus 0.6435 is equal to this 0.4510 268,118. This is all radians. 2 theta will equal to, well, I'm going to add 0.4510 and so on and so on. I'm going to add it with 0.6435. And then what I'm going to do, I'm going to take that answer, I'm going to say whatever that answer is that I'm going to get there, and I'm going to divide that answer by 2. So let's just grab the calculator. The calculator should have something already pre-installed, 0.45. So I'm going to add 0.6435 to it. That's the answer, and I'll divide it by 2. Okay, and then if I capture that, then obviously theta is going to be equal to that. Okay, therefore theta will be 0.547 radians. This is correct to 3 significant figures. Right, which is what they eventually required. I believe I'll just go back to make sure that we are within the range that they were looking for. Good. Let's go back and see. Let's say we must give it to, well, we'll give it to 3 significant figures anyway. Right, part C, we have to find the integral of f of x, integrate f of x. Now, let's just see. This is probably also going to require quite a number of things. Remember, our f of x was 12 sine x cos x plus, what was it? The way I wrote it, and the way I wrote it, let's go back to the way I wrote it when I was using all of my wits about it. It's here. So this is what I'm interested in. I'm interested in this part. In fact, I can just go ahead. Yeah, any one of these is equivalent, right? Any one of these is equivalent. So this is the one that I'm interested in. All of that is f of x. So let's take a snapshot and drag it over there so we can integrate it. So let's go back all the way to here, just rewrite and just take away this stuff over here because this is good. So I'm going to replace this with 6 sine 2x plus 8. I can actually put plus 8 there if I wanted to. Plus 8 plus 8 cos of 2x. We're going to obviously integrate with respect to x. Okay. Right, let's just clean this stuff up and let's continue. Right, I hope you are very familiar with how to integrate trig functions. Okay, so this is going to be 6 times 1 over a, that's a half, right? And let's take away that times, just put in brackets. 6 times 1 over a, and the if you integrate sine x, you get minus cos 2x, okay? Plus, if you integrate 8, it becomes 8x, plus, this is obviously going to be 8 times 1 over 2, that is our a value, times what is the integral of, well, if you integrate cosine, what you get? You get sine of 2x, okay? All of this is going to be plus c, indefinite integral. So half of 6 is 3. There's a minus there, so it's minus 3 cos 2x plus 8x. Half of 8 is 4, so plus 4 sine of 2x plus the constant of integration. Okay, that's it. We are done with that one. There's nothing to be afraid of there. Right. So please, I hope that you are familiar with your I mean, if you don't know at this stage, because you will not have this, if you have um, to integrate sine of ax plus b with respect to x, that is just going to be 1 over a times the integral of sine is nothing but what? Cosine. Sine is nothing but minus cosine, minus cos of that ax plus b plus the constant of integration. If you, obviously you can also take out, you can have minus 1 over a cos of ax plus b plus, oh my goodness, let's have that bracket nicely, plus c, constant of integration, right? You should know these things, okay? Another one, perhaps that I can add over here, if I have to write them all down. Well, I'm writing them from memory, so I might be out, but you can always compare, see if I'm on the right. If you integrate cosine of ax plus b with respect to x, that's going to be 1 over a sine of ax plus b, and that is plus the constant of integration. Remember, when you differentiate, okay, if you differentiate d by dx of cos of ax plus b, when you differentiate, you are going to use the chain rule, okay? So you are going to say, well, the derivative of cosine is sine of ax plus b, the stuff in there, and then you're going to multiply by the derivative of the stuff inside, which is what? A. Now, because you're multiplying by a, right, when you do integration, we have to divide by a. So that's like the opposite. Okay, that's what you do over there, right? So the last one that we have, if you were asked to integrate tangent of ax plus b with respect to x, then remember the tangent is sec square of ax plus b plus the constant of integration. Again, you will be multiplying with 1 over a. Right, so just make sure that at least you know this, because these things are, they're not given in your formula sheet, and we expect you to know them. Okay. Again, as I indicated, I'm writing them from memory. I'm just going to compare and see if I have written them correctly. So I'm going to pause the video. I'm going to stop there so that you can have a look and see, because this is very important that you do know how to integrate, trig functions, especially the ones that we are giving you. Okay, so the integral of the first one that I have, okay, the tangent of ax plus b. Let's see if we have perhaps not rewrote these things very badly. The sine of ax plus b, yes, that's a minus a 1 over a sine 1 over a cos of ax plus b, yeah, plus c. Where's the next one? The cosine of ax plus b is the same 1 over sine ax plus b. Good, you see, we are getting there. Then you have the tangent, obviously, and the tangent one, right? Remember, you have got the tangent one is wrong. So if you were to do the tangent one, let me just rewrite this one, because this is where I messed up a bit. Okay. So if you have with the tangent one, if we write the integral of sec square of that thing with respect to x, yes, then it's 1 over a, yeah, tangent of ax plus b plus the constant of integration. Very important. Okay, I knew somehow, that was a little bit out there, but got it at the end. Right, let's go to the next question. Question 6, we are supposed to solve an equation over here. And it's very important that you do know some of your rules, obviously, your double angles. For you might see this in your formula sheet, where you have the tangent of a plus b, that is equal to 10a plus 10b all over 1 minus, I believe, it's 10a 10b. Okay, now I don't have the formula sheet with me, but this one also is something that we just know. Okay, but what we have over here, we have 10x plus 45, and they're saying this should equal to 2 cot of x. Now cot x is the same as 1 over 10x. It's 1 over 10x. So what I'm going to do is I'm going to just rewrite 10x plus 45 in this form, but I'm going to say it's 10x, you don't use a and b, plus tangent of 45 over 1 minus 10x times tangent of 45, and this is 2 over 10x. Okay, taking from there. Now, so if you have a 2 in front, then you're going to have a 2 all the way over there, no problem. Now, tan 45, you should know this out of your head, tangent of 45, right, from your special triangles. You have a 45-degree angle here, you have another 45-degree angle here. This is a right angle, so let's say that's 1, that's 1, this is the root 2. Tangent of 45, tangent is opposite, so tangent of 45 is nothing but 1. So I have 10x, so this whole thing will be replaced by 1 over 1 minus 10x times 1, it's just going to be 10x over 2 10x. Go ahead and put this stuff in brackets because we are going to cross multiply. Then obviously if I do that, I have 10x, here I'll have 10x plus 1 is equal to 2, oopsie daisy, this is 2, 1 minus 10x, multiplying out 10x times 10x is tan square x plus 10x, if you follow. So I'm actually distributing, I'm also going to distribute here, right? This is equal to 2 minus 2 10x, and this is quadratic equation, so I have got 10 square x plus 10x plus 2 10x minus 2 is equal to 0. This should give me 10 square x plus 3 10x minus 2 is equal to 0. So let's just save and let's enter a page, or let's append a page. I really thought I can get to question 10, but I think we'll just go on. It's already past 1 in the morning hours. I just want to come to, they are giving us the domain 0 to 180 degrees. Right, there's something that you should know, that this quadratic does not factorize, okay? So I'm going to, okay, say let k equals to 10x, then my quadratic equation becomes a value of a. The value of a is 1, value of b is 3, and the value of c is negative 2. Okay, so they are taken from there. So using the quadratic equation, so before I use the quadratic equation, this is what I like to do. I like to work out what is referred to as the discriminant, which is b squared minus 4ac. So what is my b? It's 3 squared. What is my a is 1, and what is my c is negative 2. That is 9 plus 8, which is 17. Right, so now I can use my quadratic equation formula. I'll say k is equal to minus the value of b being 3, plus or minus the square root of 17 over 2 times 1. So those are going to be my two values of k. But I don't want k, I want 10x. 10x is minus 3 plus the square root of 17 over 2, or 10x is going to be minus 3 minus the square root of 17 over 2. Okay, let's calculate those particular values, those answers. I have negative 3 plus root 17 over 2. That gives me, oh, let me just capture that. And let's go back to the calculator. Let's just go and put a minus there, the place where we had, and let's just capture that as well. Let's save. Right. So what do I have now? I have my two values for 10x. I know that 10x, okay, 10x is equal to that, or 10x is equal to that. Right, what are they saying? what is the domain? The domain we are given is from 0 to 180 degrees. Very important. So our domain is between that. So let's just bring it over here. Now, if I look at this, tangent is positive, right? You still remember that here all of them is positive, and because it's between 0 and 180, okay, so in this particular one, the answer, my x is just going to be my first quadrant. Okay, so for that one, I'm going to take the inverse. My calculator is not supposed to be in degree mode. Very important that you don't get confused there, because this is in degrees. Look at the yeah, the domain. Angle should be in degrees. So the inverse tangent, I'm going to do the inverse tangent of that whole thing over there. And that whole thing was captured by taking -3. Okay, so that's -3 plus root 17. I'm a bit lazy to write all whole decimal down. Okay, upon 2. This should give me my answer, which is 29. Let's capture that again. So this is my base angle, which is also my value. So in this case, x is equal to 29.3 degrees to 1 decimal place. When we obviously, let's just move this over. Excuse me. When we are looking at the base angle here our base angle will be the inverse tangent of, without the negative, right? Just 3.56, 1555, and so on. And let's see what that angle is, because it's negative, and tangent is negative because the domain is between, so tangent will also be negative here, because here is only sign that is negative. So in order for us to find it, it's going to be that base angle. We're going to say 180 minus that base angle there. Okay, I'm going to say B for the base angle. All right, that's what we're going to get here. All right, so let's grab the calculator. Let's find the inverse tangent of. Let's take this off. 3.56, they have to be positive, right? 3.56, 155, 2813. Okay, what do we get? We get 74.31, and so on and so on and so on. That is my base angle. So that means my second solution is going to be 180 minus this 74.3165, so on and so on. Okay, that is going to give me my second one for x minus the answer. Okay, I get 105 point something. Let's just put it over here. Right, so I now have my solutions. X is 29.3 and x is 105.7. These are my solutions. Right, that was quite hectic, very, very hectic, but that's how you do it, right? So there's quite a lot that you have to apply, and you do get to the solution. Just remember that this over here is 1, that is going to give you 1. All right, obviously from here, you can use your calculator, you'll see it's exactly the same thing. Right, so if you mess up any one of those things there, then you are going to crash. Okay, question 7. Also, this is also another question that I don't really like for the learners, because I think that the learners will not be able to solve this, because if you look at the syllabus, they are saying that, they should show familiarity in particular use of sine 2a, cos 2a, tan 2a, right? Rarely do they put 4 theta there, but it doesn't matter. You know, this should just as much work the same. Right, so what is it that we are going to look at? I'm going to do stuff on the side because I have done it before. I'm going to look at cos of 2 theta, which I know is cos square theta minus sine square theta. Just have a look at the video. This is also 2 cos square theta minus 1. This is also 1 minus 2 sine square theta. Okay, this is but now if I look at how I should give my identity to, I'm going to use this one because it's supposed to be in terms of cosine, so I'm going to use that one, right? Those are the 3 that you can use, but that one is the obvious one. So this is 1, how you can use a double angle. This is 2, and that is the 3rd one for the double angle cosine. Right, so if I take the left hand side, which is now cos 4 theta plus 4 cos 2 theta plus 3, this this cos here you see where I have the 4, just want to make sure. I'm going to have 2 here at cos 4 square theta. I'm going to have 2 cos square. Okay, maybe I should write it here, because if you have 4 cos, or not just 4, let's just say, let's just expand on what we have over here, right? So what if we have cos of 4 theta? So what it will be exactly the same as the other one. So you'll still have 2 cos square, but in the place of theta now, you are going to have 2 theta, okay, minus 1. So this ultimately is what I'm going to use to replace this one here. That's what I was doing there. So that's 2 theta minus 1. So that is in the place of that whole cos 4 theta. Plus, I've got 4. Now I have another cos 2 theta over here, which I'm going to use this one over here. So that is going to be 2 cos square theta minus 1. And then obviously you should add 3. Okay. So far, so good. I hope you follow. Now, this is 2 cos square 2 theta. All right. Then I'm going to say, in fact, let's just put that, okay, let's say plus 8 cos square theta minus 4, okay, plus 3 minus 1. So I wanted all the numbers to be on one side. This gives me 2 cos square 2 theta, okay, plus 8 cos square, where we are, 8 cos square, let's just write that 8 that cos square nicely. Cos square theta, you have minus 4 plus 3 is minus 1 minus 2. Now, one more thing that I can do, I can write this cos 2 theta like this. That's what it is, right? Plus 8 cos, oops, brain is getting tired, 8 cos square theta minus 2. Then I'm again back here. I can actually also do the same thing. So I'm going to rewrite that as 2. Inside I'm going to have now 2 cos square theta minus 1, right? Remember from what we had before. All squared plus 8 cos square theta minus 2. Then I'm going to expand that bracket, okay? That means I'm going to expand 2 cos square theta minus 1 times 2 cos square theta minus 1 plus 8 cos square theta minus 2, right? That is going to be 2. I'm going to have here 4 cos. Ooh. Let's also save. We have done quite a lot, right? You must just follow. Cos square theta times cos square theta is cos 4 theta, okay? Minus, so you're going to have, just so you follow, this times that is what gave me this. Then I have that. I have minus 2 cos square theta. And I have another minus 2 cos square theta. And then I have negative 1 times negative 1, which is just plus 1. Okay. And that is plus 8 cos square theta minus 2. See why I didn't like this question for our students. That is 4 cos 4 theta minus 2 of this. This is 2 of them, so it's minus 4 cos square theta plus 1 plus 8 cos square theta minus 2. Right, let's distribute over that 2 over there. Let's multiply out by the 2. That is 8 cos 4 theta minus 8 cos square theta plus 2 plus 8 cos square theta minus 2. Now, if you have a look, you will see that this 8 cos square theta, that one cancel, that one cancel, that one cancel, leaving with 8 cos 4 theta, which is what we were supposed to prove. It's quite a lot. It's quite a lot. It's quite a lot. And again, you know, it implies that you should know your double angles and so on. It's quite a lot. It's quite a lot. I must say, I didn't like this for the learners. I don't think the learners will be able to do this type of question in an exam setup. And they should actually try to practice with it. But let's give them things that are actually within the scope of the syllabus. Right. I just want to bring down this identity because I'm going to use it for the next part. Okay, so if I bring down this identity, all right, I'm going to use it over here. That is A. They are saying solve the equation, but you can see they have a cos, right? It doesn't look exactly, the left hand side of this one doesn't look like the left hand side of that one. So what you're going to do is we are going to say cos 4 theta plus 4 cos 2 theta is identical to 8 cos 4 theta minus 3. That means I move that. So now this is exactly like that. Okay. What is it now that they are telling us? Well, they say that this stuff over here should equal to 4. So let's equal to 4. Okay, so we can't use the other one because they're identical. So it just helps then that we use, you know, the one that is much straightforward with only one, you know, trig function in it. And that should equal to 4. If we clean this up, we're going to get 8 cos 4 theta is equal to, well, that's going to be 7. Then cos 4 theta, or to the 4th theta, is going to be equal to 7 over 8. So that is the same as, this is the same as cos theta raised to the power 4. So in order for me to get rid of that power, I must take the, you guessed correctly, I must take the, it's an even root, so I must take the positive and negative root, 4th root of 7 over 8. Right. So that's a horrible decimal. What is the domain? They give us a domain between 0 and 180. So let's just bring that also down. So the domain, they say find to solve this. So we know that theta is between 180 and 0 degrees, I think included. Okay. So what does that mean for, you have two ratios over here. You have a ratio where you have a positive and a negative, and the cosine, even if that is the case, it's between 0 and 180, so we don't really care about this. So one value, our base angle, let's say B, and the other one over here, all of them are positive. So when we are looking at the positive, here only the sign is positive, so that implies that cosine will be negative here as well. So it will be 180 minus our B. So that is what we are going to do. So let's find our base angle, where we have inverse cos of the fourth root of 7 over 8. All right, let's see what that is. Let's use our calculator. Remember, your base angles will always be positive whenever you're using it. Right, so inverse is on degree mode, just to be sure. Inverse cosine of the fourth root. Now let's look where that root button is. Yeah, see, I'm getting a bit blind here. There we go. So that's the fourth root of, inside here I have 7 upon 8. No, I have to go out of the thing. Close. Hit enter. Oh, I'm just going to capture that. So that's our base angle, which is also going to be my solution for in the first quadrant. So theta is 14.7 degrees to one decimal place the solution. And in the second quadrant, theta will be 180 minus that base angle of 14.7, 14.7, so. So let's grab the calculator and see what you're gonna get. So we say 180 minus that, 180 minus that answer is 165 point so on, so on, so on. So let's just write that down as well. So theta is going to be, my other solution for theta will be 165.3. All of this to 3 or to one decimal place. Those are my solutions. Okay. Yeah, it's a lot. It's a lot that goes in there, but 3 marks. Yeah, for 3 marks, you have to put them all together in order for you to understand where you're gonna go. Okay, 3 marks. There we go. Right, we have got question 8. Question 8 is parametric equation. Now, I did say I'm going to go on to question 10. It's getting quite late, so we'll see. Well, I'm just going to do after question 9. Okay. Question 8. We are supposed to show that. So let me just write down what is my curve. This is implicit function, and I hope I've done quite a series on how to differentiate implicit functions. Okay, so it's x squared, and then you have x plus 3y minus y cubed is equal to 3. So we can actually go ahead and multiply out. This is x cubed plus 3x squared y minus y cubed is equal to 3. D by dx of x cubed plus 3x squared y minus y cubed, we're going to do d by dx of 3 as well. Now, the derivative of that constant is just going to be 0. Right, let's differentiate. And I hope you still remember how to. This is going to be 3x squared plus. Now, this is product rule that must be applied here. Product rule. I take out the constant multiple. Now it says this is our just highlight. This is what I'm working with. My u being x and my v being y. So keep the first, take the derivative of the second. If you take the derivative of the second, it's just going to be 1. Since it's y, you have to put dy dx plus keep the second, which is y, times the derivative of the first, which is nothing but 2x. Okay, I'm working in here, nothing but 2x. So the derivative of that is 2x. All right, minus, now the one on the outside, the derivative of that derive like normal, 3y squared, but you are now deriving with respect to, we're differentiating with respect to x. Okay, I think it's something that I need to write down. So that's dy dx, and that is of course equal to 0. Okay, so we are differentiating with respect to x. That's why you have dy dx when you have that. Right, let's just clean this up a bit. So that's 3x squared plus 3x squared dy dx plus 6, that is 3 times 2, 6xy minus 3y squared dy dx is equal to 0. Okay, so let's just have the terms in front of the dy dx. So that is going to be, I like to write them in front. This is dy dx over here, and everything else goes to the left side or to the right side. That's minus 3x squared. That 3x squared becomes negative, and minus 6xy. Okay, right, what is it that we're going to do? We're going to say dy dx is equal to minus 3x squared minus 6xy. We're going to divide it by that stuff in front, 3x squared minus 3y squared. Then obviously there are things that can factor. Let me just save and append a page. Okay, right, so this is equal to, take out a 3, or a negative 3 rather. If you take out a negative 3, you're going to have x squared plus 2xy, very important. Take out a negative a 3 over here, that's going to leave you with x squared minus y squared. Right, so the 3's cancel, leaving you with, because the 3's cancel, leaving you with negative, you have x squared plus 2xy all over. In fact, we can just write that negative here next to the bar, and then you have x squared minus y squared. Now when we get rid of a negative, where we have a minus in between terms, we just swap them around. So x squared plus 2xy all over y squared minus x squared. That is dy dx. Is that what we were supposed to prove? Let's just go and grab and see if we got to the correct proof. Let's save, and also let's see, is that what we are supposed to show? Ladies and gentlemen, we have takeoff. Right, so we have shown that to be the case. Now this is where I'm going to end with the work of today, or maybe I can still push ahead and do question number 9. Right. because I said I'm going to go up to question number 9, so I'm really getting tired. But let's do the parametric equations that we have, because it's also something that I have done quite a number of, of, of lessons on the channel. And we're going to use the chain rule, so that's x is equal to 2e to the 2t plus 4e to the t, okay, and then you have y equals to 5t e to the 2t. Chain rule, dy dx. So this is, remember the chain rule is dy dx is equal to dy dt times that same dt dx, okay? This is what we need to be able to establish. If we look at the red one, it's going to give us dx dt. So the red one is dx dt, okay? And if you differentiate dx dt, that is going to give you, really interesting, you're going to have that 2 times 2e to the 2t plus 4 times e to the t. That's all there is to it. Okay, you can actually literally clean it up. This becomes nothing but 4e to the 2t plus 4e to the t. Okay, that is the dx dt, but we're not looking for dx dt, we are looking for dt dx. So we're just going to swap it around, or you can consider that thing as like division. So I'm just going to say, wait, dt dx is then 1 all over 4e to the 2t plus 4e to the t. Okay, so that is dt dx. Now let's go and do the other one. The other one is dy dt. Okay, now when you have what you have over here, you have a product rule, because you have 5 times, keep the first times the derivative of the second, which is 2e to the 2t, plus keep the second, which is e to the 2t times the derivative of t, which is just 1. Okay, let's just clean it up. That's 5. Inside here, you have got 2t e to the 2t plus e to the 2t. Okay, let's just clean it up again by just distributing that 5. This is dy dt. So dy dt is 10t e to the 2t plus 5e to the 2t. That is dy dt. So we're just going to multiply them together. Okay, therefore dy dx is going to be that 10 t e to the 2t plus 5e to the 2t all over 4e to the 2t plus 4e to the t. I think we can just leave it there. Okay, we have it. Of course, you can clean it up further and so on and so on. Okay, they say find the gradient of the normal. Okay, I don't know if that is at the curve where the point crosses the axis. I believe I have find the gradient of the normal. I believe I have not finished with the question. The question says I only find dy dx in terms of t. Okay, you can see in terms of t, but then there's a second part that say, and hence find the coordinates of the stationary point. Then you give them correct to the decimal places. Now the coordinate of the station point happens when the y dx is equal to 0. So let's just include that page. Okay, and let's also save. When you are looking for stationary points, stationary points, they appear to happen when dy dx is equal to 0. So given that scenario, we just take 10 te to the 2t plus 5e to the 2t all over 4e to the 2t plus 4e to the t. We're going to let this equal to 0. Right, that denominator equals to 0, so I mean you cross multiply, you get 0, so you're going to have 10 te to the, oh my goodness, 10 te to the 2t plus 5e to the 2t is equal to 0. Alright, what is it that we can take out? We can take out 5e to the 2t, that is going to be 2t plus 1 is equal to 0. Then I have got 5e to the 2t is equal to 0, or 2t plus 1 is equal to 0. Right, so what this is going to give you is going to give you e to the 2t is equal to 0, and it cannot, because we have to take the natural log of both sides, and here t will simply be minus half. So if t is, we are not done, because we need to find the coordinates of the uh, of the turning point. If t is equal to negative a half, what is going to be x and what is going to be y? Remember, x was given to us and y was given to us over here. Let's just go and grab them. Okay. Find t in terms of t, and hence find the coordinate stationary point. The coordinates is in terms of x and y. So if we have to take a snapshot of this, we're going to substitute our value of t into each one of them in order for us to find what is x and what is y. So x would be 2e to the 2, that's negative a half, plus 4e to negative a half, and we'll see what we get. And y, subsequently, y will be 5 negative a half, okay, that's this one over here, e to negative a half, oops, c, and we'll see what we get. Okay, let's get up our calculator. Let's do the one that I have first here in black. It's 5 times negative half, okay, times e, where's my e, times e. Now 2 times negative half is just negative 1, so negative 1. What do we get? Well, we get that horrible decimal. Let's just capture it. So that's for this one over here. So let's do the x value. The x value, it's 2 e raised to the, again, that's negative 1, because you just have 2 times negative half is negative 1, plus 4 e raised to negative 0.5. Okay, let's capture that. There we have it. Right, so what are our values of our values of x? So this gives me that x comma y is 3.16, they're saying, to 2 decimal places, and negative 0.9. 2. These are the solutions. Right. Okay. We are coping. It's horrible. Past 2 already. So part B of the question says we are supposed to find the gradient of the normal. Okay, so let's just bring our gradient function. Take a snapshot. Okay, it's horrible, but I'm just gonna bring it because the way. Okay, when t is equal to 0, let's see what our gradient is, because remember we need to be able to find our gradient, and what we have there in our gradient, we have a t value, and we would like to have a numerical value. So when t is equal to 0, when t is equal to 0, dy dx is equal to 10, that is going to be times 0 times e raised to the 2 times 0 plus 5e raised to the 2 times 0. Okay, let's see what we get in a minute. Times over 4e times 2 to the 0 plus 4e to the 0. Right, this stuff on this side gives you only 0, and this one gives you 5, so that's 5 on the numerator. This is going to be 4 times 1, which is just 4, plus, this is exactly, let me see, this is 4 plus 4, that gives you 8. So if that is the gradient, so the gradient of the normal is going to be the inverse of that, negative 8 over 5. That's all that they ask in this question. They are not saying you must find the equation, all right? So that's it. If they wanted you to find the equation, you would be using those points that you got in the previous question. Right, it is 6 minutes past 2 in the morning. Again, as I said, I'm going to do question 10 and question 11 and question 12 perhaps tomorrow or later in the week. And then you can prepare for your nationals and upcoming. I found the paper to be a little bit hard for the candidates. I don't think some of the questions were justifiable enough for them, but it's good practice. And if you see me working through the problems, right, where you disagree, you can always contact me. But that is the gist of the matter, and there's quite a lot in there. And hope you have prepared well, and this somehow also helped you in a few of the things that you are struggling